Okay, ready to dive deep.
Always.
Awesome. So today we're tackling something pretty fascinating, historicist theories of scientific rationality.
Ooh, yeah.
Yeah, it's kind of flipping the script on how we usually think about science. We're taught that it's this straight path to objective truth, but historicists come in and say,
Not so fast.
exactly, like there's a whole lot more to the story.
Way more. Think of it less like a straight line and more like a winding path, shaped by all sorts of things along the way.
Right. It's like the stuff we learn in textbooks, that's just one version, right? Historicists went beyond that. They dug into the actual history of science.
They did, and they found out that, well, the so-called scientific method, it's not always so cut and dry.
Like, not every scientist followed those steps perfectly, right?
Not always. There's intuition, judgment calls, even a bit of persuasion involved.
So it's more human, messier than we might think. This is so cool. All right, so to guide us today, we've got excerpts from the Stanford Encyclopedia of Philosophy. And it looks like historicists, well, they really challenged the traditional view of science, right?
They really shook things up, especially when you had figures like, oh, what's his name?
Thomas Kuhn.
Yes, Kuhn. His book, The Structure of Scientific Revolutions, that was huge back in the 60s.
Paradigm shifts, that's what he's known for.
Exactly. He argued that science doesn't just gradually build knowledge, like brick by brick. It's more like there are these huge leaps forward, these paradigm shifts, as he called them.
It's like almost a completely new way of seeing the world.
Yeah, like think about the shift from thinking the Earth was the center of the universe to realizing, whoa, it's actually the sun.
Wow, yeah, that's a huge shift.
Totally. And those shifts, they change everything. The questions scientists ask, the tools they use, even the basic concepts they work with.
So instead of science being this steady climb up the mountain of truth,
Right.
it's more like navigating a jungle, right?
Exactly. You're going to hit obstacles, maybe have to completely change course.
But if history influences science that much, doesn't that make it kind of, I don't know, subjective?
I see what you're getting at. That's where people start to worry about relativism. Like, is anything goes?
Yeah, is there any truth at all?
But that's not what historicists are saying at all. They're not saying anything goes.
Okay, so how do they explain it?
They're trying to understand how scientific progress happens, despite all these historical influences.
So how can science still be reliable if it's so connected to its context?
Exactly. That's the puzzle they're trying to solve. And to do that, they've looked at all sorts of models and ideas.
Oh, like what?
Well, for instance, some have drawn inspiration from evolutionary models.
Evolutionary models, like survival of the fittest, but for scientific ideas.
Kind of. It's like certain concepts survive and thrive while others fade away.
Interesting. So it's this constant process of like adaptation and competition among ideas.
Exactly. Now, while all this was happening, there were these huge debates going on within historicism itself, especially back in the 60s and 70s.
Oh yeah, the Stanford Encyclopedia mentions something called the Battle of the Big Systems.
Right. That's what I'm talking about. You had all these big thinkers, Kuhn, Lakatos, Feyerabend, Lorden, each one with their own grand theory of scientific rationality.
Oh wow, so it's like a philosophical showdown.
Totally. It was like a battle of ideas, a clash of the titans.
I can't imagine those dinner parties. Okay, so we've got Kuhn and his paradigm shifts. Who else was in the mix?
Well, Lakatos, he was interesting. He agreed that history matters, but he wasn't so sure about these sudden revolutionary shifts.
So less about abrupt change.
Yeah, he proposed this idea of research programs. It's like these long-term research projects that involve gradually.
Okay, so still focusing on the historical development of ideas, but maybe a little less dramatic than Kuhn's paradigm shifts.
Yeah, more like a continuous process of refinement.
And then there's Feyerabend. He was kind of a wild card, right?
Oh, absolutely. He was all about methodological anarchism, no fixed rules for doing science.
Whoa. Anything goes is what he's famous for saying.
Yeah, that one stirred up a lot of controversy. His point was that too much rigidity can actually stifle creativity.
Okay, I see. But then how do you even talk about scientific rationality if there are no rules?
That's where things got tricky with Feyerabend. He argued that you have to look at the specific historical circumstances to see why certain ideas worked, even if they might seem irrational to us now.
So it's all about context.
Pretty much. And finally, we've got Lawden. He was more of a pragmatist.
Pragmatist meaning what?
Like, for him, the ultimate test of scientific progress was problem solving. Does a theory actually work? Does it solve the problems it sets out to solve?
So the proof is in the pudding.
Exactly. If it works, and that's how he judged the rationality of scientific decisions.
Okay, so even though they were all coming from different angles, were they all ultimately trying to grapple with the same question?
Absolutely. They were all trying to figure out how to understand scientific rationality when you take history seriously.
So it's not just about science happening in a vacuum, right?
Right. It's about understanding all these complex factors that shape scientific knowledge. And that's where things got even more interesting when sociologists entered the picture.
Oh, yeah, they brought a whole new perspective to the table,
They
right?
sure did. They really pushed the boundaries of what was considered relevant to understanding science. But we'll save that for after the break.
Stay tuned.
So sociologists came in and kind of shook things up even more.
Yeah, the Stanford Encyclopedia talks about this new wave sociology of science. What made it so new?
Well, they weren't afraid to blur the lines, between what's traditionally seen as internal to science, like the theories and experiments and all that,
Right.
and the external stuff, like the social and political context.
So they were saying that you can't really separate those two worlds?
Exactly. They were like, hey, all those social factors, they play a huge role in shaping scientific knowledge.
Like how so?
Think about it. Funding priorities, career ambitions, even just the cultural values of the time, it all influences the kind of science that gets done.
So it's like, even though science aims to be objective, there are all these human factors at play.
Totally. And that didn't sit well with everyone, let me tell you.
Oh, I bet.
You had these huge debates in the 90s, the science wars. Some scientists and philosophers felt like sociologists were attacking the very core of science, like saying it's all just a made-up story.
So it was like a battle between objective truth and social construction.
Kind of, but it was more nuanced than that, really. Not all sociologists were saying science is completely relative, and plenty of philosophers were open to the idea that social factors matter.
So it was more about finding that middle ground, right?
Yeah, trying to understand how science and society, they're all tangled up together.
Right, right. So what were some of the key ideas that came out of all this back and forth?
Well, one big one was the STRONG program developed by David Glore and Barry Barnes.
Strong program, okay?
They argued that when you're looking at science through a sociological lens, you got to be symmetrical,
Symmetrical.
meaning you explain both true and false beliefs using the same kind of social mechanisms. You don't judge whether the belief itself is right or wrong. You focus on the social processes that led to it being accepted.
Ah, I see. So it's like whether it's a scientific theory or a rumor spreading, you're looking at the how and why, not just whether it's true or not.
Exactly. It helps us see how ideas take root and spread through a community.
Fascinating. So any other big players in this new wave?
Oh, yeah. You had the BAP School, led by Harry Collins and Treasure Pinch.
Okay.
They were all about these detailed case studies of scientific controversies, showing how social factors really influenced the outcomes.
So like digging into specific examples to see how the sausage gets made.
Exactly. They wanted to show that scientific knowledge isn't just handed down from some all-knowing authority. It's messy, it's negotiated, it's a whole social process.
Right. It's not just a eureka moment. It's a whole lot of back and forth.
Absolutely. And all this sociological work, it had a ripple effect on philosophers, too.
Oh, yeah.
At first, there was some resistance, but eventually, many started to take these ideas seriously and incorporate them into their own thinking.
So it was a productive exchange, even if it got a bit heated at times.
Totally. It pushed everyone to think more deeply, to be more precise, to really grapple with the relationship between science, history, and society.
So after all that, where do things stand today? Is there any sort of agreement on how we should think about scientific rationality?
Well, in philosophy, a complete agreement is like a unicorn.
Right, elusive?
But I think it's safe to say those debates fundamentally changed how we understand science.
In what way?
Most philosophers now recognize that historical and social context, it matters. But at the same time, they also recognize that science still has some degree of objectivity, some degree of rationality.
So it's not a black and white issue.
Nope. It's about recognizing the complexities, how all these different factors are intertwined.
And that's where those newer approaches come in, right? The ones we talked about earlier.
Yes. Historical epistemology, cognitive history, they're all about trying to create more holistic pictures of science.
So it's like moving beyond the battles and trying to build something new.
Exactly. It's about embracing the messiness of science, acknowledging its limitations, but also appreciating its power.
This is all super fascinating, but I got to ask, what does it mean for us, the non-scientists? If science is shaped by all these outside forces, how can we trust it?
That's a great question. And it gets to the heart of why all this matters. It's not just about understanding the past of science. It's about figuring out how to navigate the present and the future.
So how do we navigate it? How do we balance all this? So how do we navigate it? How do we balance all this?
Well, that's where the really cool part comes in historicist theories. They're not just about pointing fingers.
Right.
They actually offer solutions. They give us a framework for making science more robust, accountable.
Okay, how do we do that?
Well, for one, we got to move away from this idea of the lone genius scientist, right? Working all alone in their lab.
The Einstein stereotype.
Exactly. Science is a team effort. It thrives on diversity, debate, all those different perspectives coming together.
So it's more about collective intelligence than individual brilliance.
Exactly. And to make that happen, we need to create spaces where scientists from all different backgrounds, disciplines can come together and really bounce ideas off each other.
That sounds great, but science can be so competitive, right? Everyone's scrambling for grants and publications.
Oh, absolutely. It's a tough environment. But historicist theories, they can help us identify those roadblocks to collaboration.
Like what?
Well, think about funding models. The way things are set up now, it often rewards individual projects over team efforts.
So we need to change the incentives.
Yeah, and it's not just funding, it's peer review, publishing, even how we teach science. It's about creating a system that supports ethical, responsible practices.
So it's not just about changing the culture of science, it's about changing the systems that shape how science is done.
Exactly. And historicist theories can help us pinpoint those systemic biases that might be lurking beneath the surface.
This has been such a mind-blowing conversation. I feel like I have a whole new understanding of what science is all about.
Me too. It's been a pleasure diving into this with you.
So to wrap things up, I think we should leave our listeners with a question to ponder, something to really chew on.
I like it. Let's do it.
If scientific rationality is always evolving, what does that mean for the future of science? Will our current ways of doing things one day seem as outdated as, I don't know, using leashes to cure diseases? What new ways of thinking of exploring the world might emerge?
Ooh, that's a good one. That's something to think about.
Definitely food for thought. That's all the time we have for today's Deep Dive.
Thanks for listening, everyone.
And keep exploring.